Hello, everyone, and welcome. Thank you for joining us for today's session. My name is Firas, and I'm the event planner for Microsoft Reactor in Redmond. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary and stay professional and on topic. The session is recorded. It will be available on the Microsoft Reactor YouTube channel in 24 to 48 hours. I'll be sharing the link to the YouTube channel on the chat. I'll also be sharing the link to our survey so you can let us know how this event went. And I'll also be sharing a link for our Meetup page so you can see what events we have. Which brings us to our session today. Our session will run approximately from an hour to an hour and a half. Our speaker for today is Armando Lacerda. He's an Azure Data Platform architect and engineer. I'm gonna pass this now to Armando.
Thank you for us, and good morning, good evening, good afternoon, wherever you're connecting from. Good evening from here in Florida, and also down there in California, where for us is located. Great to have you here for this live session or through the recording on YouTube. And the goal of this session today is to share some knowledge and go through some steps and apply machine learning regression models into some data. Let me bring up here my slide deck just quick. Over here, there we go. Once again, my name is Armando Lacerda, and as far as mentioned, I am a data architect and a data engineer. I used to work, I used to be a DBA, to introduce myself as a DBA and a consultant on the data platform, but now we are most into AI and supporting data scientists to work with the data, so we prepare the data and data engineering aspects of the job. I'm also a Microsoft MVP, which means Microsoft has awarded me with this title, which stands for people who like to go into the community and share their technical expertise, either through blogs or participating on Q&A sessions or sessions like this one here. So you could be considered as an MVP too if you start sharing what you know on public settings, or put a website up and start your blog. And if you get noticed, you can be nominated and perhaps getting the award. I'm also a Microsoft MCT. I have my pointer here someplace. There we go. I'm also a Microsoft MCT, this red one here, which means I'm certified to teach Microsoft official classes, and I've been doing that for over 25 years, over 26 years actually. And it's something that I really like. I love to be in the classroom. I love to learn from the students' experience and share whatever I can share on particular subjects. I hold multiple Microsoft certifications. These are some of the certifications here in the slide deck. My MCT certification, developer certification. Start as a developer a long time ago. I consider myself a recovering developer now because I don't do web applications anymore. I used to do desktop applications. Now the code that I do is for data engineering and for AI. But still code, right? So my developer certification there. I do lead Open Hacks, which is another learning modality from Microsoft. When they give you challenges and you're supposed to progress through the challenges, and when you are done, when you've accomplished the goal, you get the badge like that one in there. And it's a fun activity. If you have a chance, if you look it online, Microsoft Open Hacks, they have open sessions there. It's not for the faint of heart. these open hack sessions, they really take hard on you because you have to find your way through. There is no lab instructions like you're gonna see here, but they are fun. They're very challenging. And some other role-based certifications is the current Microsoft set of certifications that you can get. This particular session is two-folded. There are two goals for this session. The first goal is to introduce you the Microsoft Learn website. And the Microsoft Learn website is a Microsoft decision of the courseware material that used to be given to students in classroom, meaning you have to pay to go into the classroom And when you get there in the classroom, you get the courseware material. There was no other way to get that courseware material. Now, Microsoft decided to make those courseware materials that we use in the classroom available for free on the Microsoft Learn platform. And I'm going to show you the website in a second. So this particular session, one of the goals of this session is exactly that, is to promote the Microsoft Learn website and invite you to go in there and explore the learning paths there are in there. The learning paths for multiple Microsoft technologies and Azure Cloud Services. There are also open source material there for you to learn. I just presented a session this week on Python, and there are multiple other sessions here on the Reactor on open source technologies that Microsoft has embraced and now support in their cloud service. And this particular one here is one of them, but it's not in the learning path. Today it's a special one. You're gonna find the content here. Gonna show you the links in a second. Actually, Faraz is gonna share the links with you in a second. But this one is still in GitHub. They have not been published through the Microsoft Learn website. So that is one thing. The other thing is to show you how you can do the exercises, right? How you can do and practice this, everything you're gonna do here on your own. So the steps are there, the elements are there. I'm gonna show you how to do it. And after we wrap up the session here today, you can go ahead, jump in your computer and install the software, the prerequisites if they are not already installed on your computer. And you can start playing with this thing right away, just following the instructions I'm gonna show you. The agenda for the next hour or so is going to be a brief introduction to machine learning, where what is it, where it comes from, what are the main elements of machine learning in terms of getting something done, the workflow, and then we're gonna go straight into the workshop. It's very hands-on, very demo-based. The code is all there, and we're gonna investigate the code together and see how it works. So let's go for it. When we talk artificial intelligence, what do we mean by that? When people ask you, what is artificial intelligence? How would you explain artificial intelligence? The actual definition, if you go to the dictionary, you're going to find something in there. If you go to Wikipedia, you're going to find something in there. But sometimes the definition they're not in agreement. There's a kind of a gray area between artificial intelligence, machine learning, and data science in the middle. So at some point, we need to pick a vendor and see how that vendor implements and uses this terminology so we don't go crazy, right? So the idea of artificial intelligence from Microsoft perspective, it's kind of an umbrella name for multiple services that are available in Azure, in the cloud platform, and also the desktop for data science. So in artificial intelligence, from Microsoft perspective, you have two branches. You have cognitive services and you have machine learning. We have presented, there is another session here on the playlist and in the Reactor about how to use some of the services from the cognitive service, the compute vision, and a few other ones. So you can go ahead and take a look on those links there. Just do a quick search and you're gonna find them. So the cognitive service are machine learning models that have been already trained by Microsoft's team, and they are available for you for a price because they put the hours to train the models. So now you want to get something done for you using artificial intelligence. You use the cognitive service with the pre-trained models, and you pay by the usage, right? By the amount of calls you make to the API. On the other hand, if you have a particular case that's very specific to your business, it's you cannot find a model out there in the market that's already trained for what you're trying to do, then you have to do machine learning. So the machine learning is where we're going to focus on this session, is when you start creating your models from scratch. And therefore, they are your models. You usually don't pay to use them because they're yours. Right? When you do cognitive service, you pay by the usage of those cognitive service pre-trained models. But when you created yours, you don't pay for the model you have created, right? There will be no sense on that one. On the other hand, you do pay for the time that it takes to train the model, because you're going to bring data in, you're going to use compute at scale in the cloud to get the model trained. In this particular session, we will not be doing this. We could, but we're going to keep it super simple. But when you work with massive amount of data, then you pay for the time you train. And in order to get a trained model so you can use in production to address your business needs, you go through the data science life cycle for machine learning model training. And the life cycle goes like this. The whole idea of creating a model is to mimic how human beings would make decisions based on a business case and business goal for that case. Got that? Right? The whole idea of machine learning training, creating a model, machine learning model, therefore, creating an artificial intelligence asset, is to mimic how human beings would make decisions on a particular context, on a particular business goal, on a particular business area. And the whole objective of that is to scale decision making, right? So the whole point in here is like in our workshop, in the steps we're going to be running in the field, we're going to create a model. We're going to train a model that will make decisions on a loan approval. I think it's loan approvals. So if there was no artificial intelligence available for that, I would have to hire people as my business grows so they can make decisions on those loan approvals. Should I approve this loan? Should I approve this loan? So I have a collection of data to analyze and assess if that person can, if it would be too risky to give a loan to that particular applicant. So that's the idea. Instead of hiring more people to do my business, I can simulate how people, I can code, I'd rather say, how people would make decisions based on a set of data, and then scale that decision making up in the cloud, right? We're using compute in the cloud, so I can do thousands of analysis per second. Actually, this kind of model is heavily used on credit card transaction processing to try to detect fraudulent transactions. So it gets all the whole context of that transaction, and they don't have a person who, seeing every single transaction that goes through. They have computing power using artificial intelligence, using trained machine learning models to make those decisions and flag possible fraudulent transactions. So the first thing, in order to get the whole the model trained, is to define the business within the business context, define a particular business goal. And that business goal must be very specific. The idea is not like the idea is not trying to be vague in the sense like should I wear this kind of clothes or that kind of clothes? Should I go to should I take a vacation or should I go to work? These are very vague ones. Where should I go? Not being very specific about a particular question. In our case here, we are going to be very specific on the question. In the workshop, the question will be: should this application be approved or not? So it's very specific and very narrow in terms of results, yes or no, right? It could be a definition of a price range, for instance, or a range of values. So it depends on what kind of a question. What will be the estimated value for this car? So there will be a price range for the car based on the information grabbed from the car. So the point is, you have a very specific question and only one question to answer. That's a very important thing too. And so in order to do this, you as a data scientist, one that knows about how to do coding, probably in Python. The Python is going to be our language of choice here today. you're going to do coding and you know how to do coding, how to use the libraries, you need to pair up with SME, right? A subject matter expert, an SME of that particular business context, so they can guide you on the elements of the business. Because we are experts on the computing side of it, but on the business side of it, they can fill up some of the gaps that the data may lack. And we're going to see that as we move along. So that is step number one. Step number two is where you're going to spend most of your time, which is once you know what is the question you're trying to answer, you make a calculation for that. You have spoke with your subject matter expert, and it's going to tell you what is the data you should be analyzing to get to that conclusion. The next step is collecting the data that's available for you to start training your model, and look at the data quality. Start working on the quality of the data to make sure that the data is okay to be sent for model training. Machine learning models, these models, they are nothing but, I mean, for the most part, they're nothing but statistical models. It's all about statistics. That's why one of the reasons that data science is involved in here, because it's all about statistics. You want to, when you see a collection of data in a particular set of data, there is a statistical probability that that data represents this answer or that answer, and so far, so on. So as a data scientist, you're going to spend a lot of time. It's going to be long hours working with the data, trying to understand the data, profiling the data, filling up gaps, discarding things that are not relevant to the context, and putting all the entire data set together. And this data set together is known as a data frame, or DF for short, when you do coding. It is a data frame. A data frame is like an Excel spreadsheet in memory, so you don't, it's not visual. You interact with the data frame by code. So it's like an Excel spreadsheet. It has columns and rows with data. Those columns are usually known as features, while the rows can be either rows or can be tuples, depending on which school, which book you are reading. And the question you're trying to answer, the column on the data frame that will hold the calculated question, the calculated answer, is going to be named label. So a data frame is a collection of features and a label, right? And you're going to fill up that data frame with data and train your model. So in order to train your model, you need to collect the data, make sure the data is ready. You have removed any kind of noise that could be there in the data, and we're going to do that as we go into the workbook. And once the data looks good, we pick up the next step. We pick up a particular model, because there are dozens of models out there. Depending on the language you're working with, you're going to have even a couple hundreds of models you can use, because they're all statistical models. As a data scientist, you should be a subject matter expert on understanding these models and what are the characteristics of these models, how they do their calculation, if they apply, if they are well suited, if they're applicable to a particular business context, depending on how the data behaves in that business context. So once you clean up the data, and again, you spend a lot of time cleaning up the data, the next stage is using that data to train your model and pick up a model that will better suit the data you are analyzing, that can better predict the data, the results, right, you're looking for. And this is also a very time-consuming task. But at this point, you're gonna train one in small sets just to see how the results look like in small sets. And then more likely, you're gonna leverage cloud computing to go through the same structure of data structure, but with way more volume, so the predictions can be more precise. So we get hundreds of gigabytes, perhaps even dozens of terabytes, and process your data, process that data through the model to get a well-trained model. And that's what we do. Once that's done, we just push it to production. We handle it over for the operation people, so the operation can get that model, whatever the model is supposed to work. That's the life cycle, right, of a data scientist that's focused on creating trained machine learning models to help business in the production line. One second. Sorry about that. End of the day, it's kind of getting tired. Okay, so I found this picture here on the web when I was preparing this slide deck for this session here. I found it super cool. It was, well, I like the style of this one. And I apologize, I don't have the link for this page. The guy did a really good job. I'm gonna find this link later and put there on the comments on the YouTube channel. But this one here shows that when you are talking about training a model, training a model is something that happens when you are doing supervised learning. Because when you do machine learning, you have two branches of possible models you can apply to a particular business context. You can have supervised or unsupervised models, and therefore supervised or unsupervised learning. We're not going to deal with unsupervised learning, but the idea of the unsupervised learning is like the model is supposed to take the data that's coming in, and as the data comes in, it starts understanding the basic structures of the data. It's usually streaming kind of a data or a very complex combination of data where patterns will be found on that data volume. Compute vision, right? When you do image recognition, these things, they rely on this unsupervised learning. They look into the patterns, they identify the patterns, and then you name those patterns so you can start labeling the common structures that have been found. And that's the idea of the unsupervised one. The very first project that I did back 10 years ago or so, when I took my first free online class like this one here from MIT, was on unsupervised models, where you have a microphone, you have two speakers, two people talking to the microphone, and the model has to separate both voices, recognize one speaker and the other, and suppress the background noise. Just keep just the two voices and identify the two voices. So this is kind of unsupervised learning that's super interesting too, but we're not going to focus on that one here in this workshop. What we'll be doing is this other one here on the supervised learning. And usually you use that one here when your business case is around data that needs to be categorized. Usually you're either trying to do predictions or be predictive into the future, or the current immediate context based on what you have seen in the past. So you can do either classification or regression. Usually do classification when you try to identify elements, like identify fraud detection, like I mentioned before. You know, a common example here, right? Divides the socks by color. So you're doing classification. You know that you have socks, and then you have to identify what possible colors there are and make them cluster together. Or you can do regression when you want to divide the ties by the length, right? When you want to define the elements of the incoming data and make decisions like yes or no, true or false, things like that, not into a range of data. So yeah, so we'll be working on this one here, right? We'll be working on supervised learning, and we're gonna have an example of how the data, this pipeline goes through from end to end. It's a very basic one, not that much data, but I'm sure it's gonna be fun. If you have any questions, right, please write your questions on the chat window. And at the end of the presentation, I will go through the questions and provide you the answers if I have the answers. So let's go ahead and, oops, no, it's not the end yet. Let's go ahead and jump into our environment. So let me call here my virtual machine, which is this one here. And let me make my environment here bigger. Got this screen there bigger, put myself here in the corner on the left. And this is Visual Studio. So let me get over here and bring the page that you guys are going to be using. This one here. First, the Microsoft Learn website is aka.ms/learn. This is the shortcut to get into the main page, the front page of the Microsoft Learn, where Microsoft put all the courseware that I mentioned and much more, not just the courseware that was in the classroom, but there is way more content in here actually, about Microsoft technologies, both proprietary Microsoft technologies or open source Microsoft technology that Microsoft has adopted. You got a bunch in here, right? Here they're telling you some of the populars they have seen people browsing over. You see, Microsoft Azure Fundamentals describe Azure services. One of them, which one is this one? Azure Fundamentals. All right. And if you want to learn about artificial intelligence, for instance, right, machine learning, these things, you can just do a search in here and do like machine learning. And then you see a few of machine learning topics in here. You can go ahead and click on this one and start following the learning path. In this particular one, this first module has these topics, and there will be more modules as we move along into the learning path. And the fun thing about this one here is that if you log in, you can collect these points, and as you accrue points, you get badges, and then you can show in your transcript. They keep a profile of how many hours you have invested, average hours, they estimate these hours, how many hours you have invested and what topics you have been studying. So you have your transcript on this side here. It's not a certification, but it's a good place to show that you're someone that invests in your own skills, right? To perfect your own skills. So yeah, so this is the site. For this session today, our content is not here, but for many other sessions we have done in the past, the content is here, and I highly recommend you to take a look on this one here. For our session today, the content is in this page, and for us is going to share with you the link for this page here that has a Jupyter notebook with all the lab steps we're going to be doing, right? All the exercise steps we'll be doing. So once you get to this page in here, as you can notice in here, this page, this GitHub repository holds a notebook, a long notebook, which is the actual steps, the guide for this workshop. So your goal, what you got to do is download this file. There will be 3 files to download. This is one of them. And in order to download this file, in case you are not familiar with GitHub, you have here, when you're browsing the file, you can see here the file. This is a Jupyter notebook. GitHub understands Jupyter notebook and kind of renders it on the screen here. But if you want to download just this file, you have to go ahead and click in the raw button. You want to see the raw, the actual data, right? The actual file itself, the content of the file. So we're going to see raw. This is the JSON representation of that file. And when you get in here, you're going to press Control S to save this file, and you're going to save this file someplace. Now, notice that when you do Control S here, like I've done, it changed the extension to TXT, right? Like this is a text file. We know it's not. This thing is a Jupyter notebook file, a Python code, Jupyter notebook with Python. So what we really want to do is remove that extension from there. 1, 2, 3, 4. Remove that extension and save the file. I already have it saved in there. Let me change this one here to all files. I already have it saved over here. See, I have downloaded it before, so I'm not going to download it again. But that's how you do it, right? To download the file. The other link that for us is going to share with you is the one where the sample data is hosted, right? They keep the sample data. And the link is going to be there on the chat window for you to click and get to this repo. Here's the same repo. It's just another folder in the same repo. And there are 3 files in here. From these 3 files, you're going to download just 2, right? The third one that's in there, just in case someone wants to compare results. But these are the 2 files we need to download, right? These 2 guys in here. the loan prediction training data and the loan prediction test data. Both are comma separated value files. And you download them the same way. You click on the file. GitHub is going to render as a table because it understands CSV. And then you're going to click on the raw button again and press Control S to save this file. Well, this is not written there, but they suggest to write keep that file on a subfolder called data. So I do have my subfolder data in here, where I have already downloaded the files. So if you can recall, create a subfolder there and save your files there. Otherwise, you just have to do minor changes on the notebook to point to whatever the file is located. Once you have both files downloaded, the next step is to open Visual Studio Code, to start Visual Studio Code. In case you don't have Visual Studio Code, you can download it for free. It's a Microsoft tool for coding, and you get it from the web, Visual Studio Code download, right? You can Bing or Google it by the name. Where is it? Come on, show me. There we go. Visual Studio Code download, right? It's just search for that one. It should be the first page in there. There we go. Download Visual Studio Code, and it works on all platforms. So this exercise here will work on either Windows or Mac or Linux, any platforms. Super open source, super portable. You click on the button, you download the software, and you should be good to go. Once you have the software installed, and here it is, you're gonna open the folder, open folder where you have saved your files. In my case here, I saved on a folder called Reactor. This is the folder where my files are, and these are the files. This is the subfolder with the data, and these are some of the files. I have more files than you will have, because I have presented other sessions and I have used the other files for the other sessions. But the file we have just downloaded from the repo is right here, right? It's the very first one here on the list. So this Rocket book you see here, it's another session. I actually presented this session yesterday. If you are watching recording, when was yesterday? It doesn't matter. Just look on the YouTube channel on the playlist, you'll find it there. So I'm going to open that file we just downloaded, and this is the workbook where you're going to spend the rest of our time here together, understanding the process of the data scientist to get a trained model, right? So all of this was just sort of a prerequisite. And in terms of prerequisites, there are some other elements I recommend you to download. Even before open the Jupyter Notebook file, I would recommend you to click here on the extensions tab of Visual Studio and download the Jupyter extension. You see I have my one already installed. It's already installed, so I have the option to install here. Download the Jupyter extension so you have a better experience with the Jupyter Notebook and connecting to environments for processing and code execution. That is one. And the other one is, because you're going to be using Python here, you should also download Python, right? You must actually download Python. Python download from the Python project, right? This is the project there, and you have a button there to download. I have already downloaded my one. I am the latest version on this virtual machine here that I have in the cloud, and I'm good to go. The way you can check that I have that is by going into the terminal. If you are using Windows 11, in my case here. Otherwise, you have other ways to get to the command prompt, to the terminal, and you can do Python -- version. If you don't get an error message, it's because Python is installed, and it will report which version is installed. In my case here, version 3.10, like I mentioned before. So with all of this installed, we are ready to go into the notebook. So let me go back there to the notebook. Let me close this tab here. Don't need that one. This is the notebook. All right. So again, talk to me. Now, we're not going to invest in that time here in this session. Me, the subject matter expert, me has already given us all the information that I need. It's on the text that you're going to read on your own time. I'm not going to waste your time here, right, reading these things for you. I'm just going to highlight elements. I think this font here is big enough for you guys to read. If it's too small, let me know, right? For us, it's going to call me on audio here and let me know if it's too small. So the subject matter expert told us that this is the data we should be working with. A loan application would come with this information. This is very narrowed down, right? It's super small. It's just for a sample use case in here. Of course, it will be way more complex than this, but you got the idea. So I got all of this data, and these are the features that we have in my data frame, and this is what they mean. And what data should I expect on this one? Like, is the person self-employed? Yes or no? Is the person married? Yes or no? What else? Co-applicant home. Income, sorry, income, home. Why did I see home there? So the income of a co-applicant, if there is one, right? Loan amount in thousands, and so far, so on. These are the information we will be receiving, and we'll be doing profiling on this data. The problem here, again, is make the decision on whether to approve or not to approve a loan application. Now, there is a call out here. There's a call out here for ethical practices in ethical practices in using machine learning. Why? Because I already explained to you, machine learning, the goal of machine learning is to replace human beings on decision making and predictions and proactively doing things to accomplish a goal or prevent something. And if the machine learning is not well trained, if there is some bias on the data that trained the machine learning model, because the model itself, it has its own bias in terms of calculation, but the actual bias of the predictions will be from the training information, the training data that's coming from the sources. And you must be very ethical when doing the training and avoiding taking considerations of features that would harm a particular group of people for whatever categorization profiling we want to do to them, right? Like gender, marital status, something that should not be a factor in terms of ethical concerns to make a decision on some aspect of the business. So there is a discussion about that one here. Microsoft is super serious about this. I mean, you have no idea. I just got an email, I think it was last week or the beginning of this week. I got an email from Microsoft. The computer vision that's there in cognitive service today can try to detect if a person is happy or not so happy or frown or something. If there is facial hair or not, right? What kind of hair the hair and makeup are on the person. So with that information, you can kind of this must be a man or a woman, not necessarily, but you can try to go around trying to figure that out if gender information is not there. Now, Microsoft came to the conclusion that people were misusing these features. They're there working, but Microsoft, considering the ethical practices, they're like, you know what? We're going to retire. We're going to disable these features that are working but have been misused. So they sent an email out a few days ago. So they're gonna remove those features from the compute vision in cognitive service. That's how serious Microsoft is about using AI in a fair way, right? Using a fair way. In this particular use case here, they are gonna tell us that they're gonna we in our data sets over here. We have, if I zoom in, it's going to be too big. Let's see. Where is it? One is here. Oh, here, up top. We have these two features in our incoming data sets. If about the gender and if the applicant is married or not married. And we're going to use these two pieces of information that we have gotten as an example of something that could profile a person in a particular way, and could be harmful in terms of the decision making. So we're going to remove. We are receiving this data, is in the data set, but we are going to just consider it for machine learning purpose. All right, cool. So ethical practice in there. Here in the workbook, they have kind of the same idea that I show you in 4 steps. Here they have in 7 steps. So you understand the domain, you make a plan, and that's the question you want to answer. You explore the data, you clean up the data. Once the data is ready, you train your model, you score your model to see if your model had good performance. If it's acceptable, you deploy the model. So kind of the same thing we discussed before. Here's the plan. You're going to use logistical regression for this one here. And in order to do this logistical regression, like I said, we're going to use Visual Studio Code for our coding environment, and we're going to use Python as the language to write our codes, right, to do all these tasks. Because when you need the computer to do something for you, you have to write code with instructions about the tasks to be done. And we're going to use Python here. In case you're not very familiar with Python, remember that we have in the Reactor playlist, we have some sessions there about getting started with Python through the Microsoft Learn resource that's there for you for free. In this case here, they are telling us we are going to use 3 particular libraries in Python, because Python is just the language. Libraries are code people have already created to do some sort of a calculation, do some sort of processing for us. Like if I want to show a picture on the screen, there is a library for me to do that. I just need to have a code to load the picture and send to the screen. The library will render the picture on the screen for me. In this case here, both the overall math calculations and the specific machine learning statistical models, there are a library for these guys. They are using here pandas for that, and the matplotlib to show results on the cell here on the Jupyter notebook, along with the math library NumPy. So to make sure that these things are there, I'm going to pop up here the command line. Whoops, there we go. Come on. I'm going to pop up here the command line. And the way to get that, usually we do keyboard stuff, right? Keyboard shortcuts. So control tick, that key there, just under the escape key on your keyboard. Control tick will pop it up there for you. There's someone in here you can also ask to see the guy. Let's see here, view. Somewhere in here, I don't remember. Open view, extension testings. I don't know. It's there somewhere. Anyways, you get the terminal. I think if I press F1, the command palette, and look for terminal. And there you go. Terminal clear. You got the options here. Where is it here? Terminal clear, open the terminal, and you can do the elements, open new terminal, external terminal, and this will pop up. All right, so in here, I'm going to use the Python package installer, pip command, install, and the library, NumPy. So that one is already installed. See, requirements already satisfied. The library is already there. The same thing for the matplotlib, already there. And the last one, pip install pandas. They're all already installed. I just showed you how to install in case you don't have it. Oops, there we go. So now that I have downloaded the libraries into the file storage on the local computer where I'm running this, I can go ahead and run the cell. And if everything goes okay, the cell runs without a problem. I got the check mark in here. Notice that this cell is not, it does import the libraries to the execution context in Python and in the notebook, right? It imports this guy here, but it also loads the file we want to work with. And notice that it used the pandas library. Pandas library got an alias here, right? A nickname PD. So it's calling from the pandas library PD. It's calling a particular method in there called read CSV files. And this is the file we have just downloaded, right? This is the file we have just downloaded. And again, I downloaded to the data subfolder. And as you can see here on File Explorer, the data subfolder is right here. If I did not have the data subfolder, if the file was here or was out of position, was someplace else, when you run this cell here, you will get an error message. Like I put an X in here and execute this cell again. It's going to tell you that you cannot find the file. So if you cannot find the data files, because there is something wrong where you place the file. So let me run this again, and now I have the data. Great, and start working. Right, I got the data. So let's take a look on the data itself. Yeah, so this data here, this particular code here, as it says over here, is just to check if the method was able to read and populate the file there.
Narrator dialog.
Oops.
Okay. Button.
Turn off that
Exiting
guy.
narrator.
Instead of pressing Control Alt Enter to execute a cell, I press Control Windows Enter, the Windows key Enter, and the narrator came into place. All right. Sometimes when you execute these cells, they give you this message here, like the results to show on the cell, the result pane of the cell is too large. So if you want to see the whole thing, you just click on the link in there, and they get the whole thing, the whole final results someplace else, right? So no biggie here. It was just to see this output. Let's actually take a look on the data. So this is the next step. You see, let's take a look on the data. What do I have in there? Tell me what the structure of the data you have just loaded. So there you go. I got applicant income. I got co-applicant income. Got all these features we had seen that we do have in the CSV file. By the way, let me open here one just for you to see. We read the training one, right? When we went for training. And then you got the loan ID, the gender, the marriage. The income is going to be here in one of these. There you go. Income, co-applicant income, and applicant's income, right? The two columns we have seen in there. So that particular call here that describes show you some of the elements that are there in the data frame. So notice that it brought in the CSV file into memory, and we already referenced that data structure, the data set, as a data frame. And I see that there are some statistical information about these guys here. So this is the amount of rows that I have with data. Notice that some rows don't have a value for the loan amount. So they're missing. I want to borrow money. How much? I don't know. I just want to borrow money. Would you lend me money? So and not all applications have the loan amount term. I want a loan, and I want a loan in 12 months, but I don't know how much. And so far, so on. So we got the counting there, and some data distribution, some data profiling. And this is what data scientists do, right? Data scientists, they come in here, they come and get the data, start investigating the data. Another method they show over here that failed. No, actually worked. Yeah. Another method they show over here is to show the table the data frame structure. So these are the columns we have seen, and these are the amount of rows with data on those columns. They call it. You see that they call it columns in here on this particular library we are working. But usually you see people calling this features, right? Because these are features describing a particular application, So they got the loan ID, 614 rows have that. It seems that I have 614 entries or tuples or rows. So all rows have an ID. Every other row out there is missing some piece of data of these columns in here, meaning there is no data there, and I have to make a decision about what to do with those rows missing data. It's part of the data cleansing, data preparation. And down here, we see that the property area and the loan status are the two columns that are filled up for all the rows. Now notice that this one here, because this data set is for training, this is representative of the past, of the history of the company, and this particular business side of the company. So this particular column is actually my label. This one here is whether the application was approved or not. And we're going to use this one to train the model so we can make decisions on new incoming applications. All right. So here are some explanations on the described function we have just seen. They point out that there are some columns that are non-numeric. And here they're going to show two of them, right? The gender and the marriage. Actually, they're not going to show. They're actually going to apply that particular ethical criteria they decide to apply here. And like I have received in a data frame these two columns, but I don't want to work with these two columns. I want to remove these two columns. It's not going to be part of the decision making when I train my model. So we're going to notice that over here, those columns were there, right there, 1 and 2. And we're going to run this guy here. Control-Alt-Enter. And execute it. It's already there. And if I look into the data structure again, go back to this cell here and look at the data frame info, those two columns are not there anymore. So they use a particular method of the data frame to drop data from the data frame. In this case, it's going to be columns, and they name the two columns. And they say, data frames, they're immutable. You're not supposed to change data frames. So when we get the data in, if we want to make any change, we create new data frames as we move along in the process, creating new data structures, because usually they're large, they're not that small, like just 600 rows or so, just over 600 rows. That in place parameter in here for the drop just tells, redo this data frame in memory, don't want to save and get it back. All right. So this one here drops the columns. This one here is like, now I have a data frame that's kind of the data frame I want to work with. If I have to retrain this model later, I don't want to go to the process of removing two columns. That was super simple. I could do it again over and over, right? But if the process of removing, changing data, realign data, it's kind of a complex one, you usually want to, save your work in the middle of your steps. Because remember, this data is in memory. If there is a problem in the data center where my virtual machine is running and this virtual machine goes down, I'm going to lose my data. I have to reprocess it. So here it's just a tip, right? Let's go and save that model there. I mean, the data framing there. But let's name it differently, because now it doesn't have the gender and the marital status. So let's run this one here. It just wrote the file to the disk, and now I have the new file right there without the two columns we just removed. So if I need to pick up down the roads from that file, what was the data the data set, the data frame I used to train the model? I have it persisted in here, and I can run the training again and get the same results again. You do want to do these things, right? Keep track and the history of the assets you are working on. All right, so this one here, we'll go, this three next cells here, we'll go over the data we find on each one of these features. So this one here is self-employed. There are 500 no's and 82 yes, right? And the data frame reports this column as an integer. Well, no and yes, an integer. Okay. This one here for the property area, they are getting a loan to buy for. They're trying to get a loan to buy. So semi-urban, urban, and rural. So there you go. That's the distribution of the data. And this here on the education, graduated or not graduated, is the distribution as well. So what are we doing here? We are profiling the data, understanding how the data is distributed. Usually you want to have a lot of specific distinct values in here in order to have a good data distribution. Our data set here is super small. So everything is like miniature, really, really small, just to avoid getting slowness when training the data. but usually you get more data than that. On this one here, you are working with the data frame, and we are looking into the application income, and we want to take a look. Right, we ask for a histogram of how the data, the income is, the range of the data of the income data is distributed. So you see that majority of our applicants, they are in this range here, right? It's just over 60,000 or perhaps $70,000 probably in a year. And this is the amount of applicants we have, right? Over 200 with that ranging there. And then we get some outliers down here. We got over 800. Yeah, no, actually this is 10,000. So this is, I read too quickly. This is 10,000. I thought that was 100. So that's not year. It's probably monthly or weekly, whatever income it is. So there are some outliers in here. The bulk of my data in terms of income is in this corner here. All right, so we are learning about the data, not doing any changes yet. This one here is using another library, the box plot. So this is the box plot about the application income. It's the same data, but now you see the distribution vertically and where you find your median, right? Your median is located, and you get the outliers, right? More isolated, right? More visually detectable in there. So there we go again. The bulk of my the median and the median and the deviations showing up in there. Now let's do a profiling on the box plot, taking consideration the application income and the education. And we see here that the kind of most of these people here are doing their application, they are non-graduates, right? When you get some of them here at the top of the medium, they have some graduation, and the same goes over here. All right, the data of the life of a data scientist, going to these elements and looking what they show for us, right? Now histogram here in the loan amounts. What's the what's the range of loan amounts that are being requested? This one here again doing a box plot on the same information and repeating the same analysis for not for the income but for the loan amount. And again, we see some common clusterization of the data in there, right? Our non-graduated are also working among the loan amounts in the same range, both graduated and not graduated. Okay, and in terms of employment, we get here the no NES for the self-employed, and again the loan amount kind of meeting the range for both of them in the same place. The self-employed, it seems like they have more distributions on the high side. Perhaps they also want to invest in the business. This particular cell, the left it alone, is like, if you want to try something on your own, go ahead and look at the documentation of the data frame library and the matplot library, actually, and try to get other visuals going on in there for you. Okay. Yeah, we're good on time. We are almost done with this. So in this second portion here of the notebook, then we start looking into the data and see how the data behaviors on the element. So here again, we are into the data, we work with the data frame, look into the credit history, and we want to count how many the distinct values and how many elements are for those, how many occurrences are for those values. So value counts is going to be a result in the frame. And in here on this data frame for this particular result, this is a data frame, another data frame here. You see in Python attributing the result of that call to another variable. So it's going to be the plot for, actually going to be a pivot table. We're going to rearrange the data here for the loan status and the credit history. I'm going to rearrange that into the map to find the mean here. Where is it? Here. To find the mean sorry, not that one. This one. Find the mean on the credit history, right? With some what is it? If the loan status, right? If it was approved or not based on the credit history that was defined in there. This is not machine learning training yet. I'm probing the data to see what I can learn for myself about the data, and then perhaps do some data changing, looking for outliers and see if it should, smooth some of the curves there in the data, some bias on the data. So there we go, the frequency table of credit history. We have 89 and 475 as the range for the elements in the pivot that was in there. And the probability of getting loan based on your credit history, as you get close to zero, whatever range they are in there, because they make the conversion of the range from the credit history, the minimal value, maximal value. So this is not a credit history of zero, is the lowest value that was found in the credit history, perhaps a 500 something, and you have 7% chance of getting approved. Probably you know someone there. I knew someone in there. And this is the highest one, 800 score, 900 score. And this is the probability to get a loan based on a credit score like the highest one. And in order to see those information, see the lowest score was 89. The highest score was 475. Oh, right. Very low credit scores here. All right. Moving on, here they give you more challenges for you to do some data exploration. In here, they use a particular library that we have already imported, the matplotlib with the pyplot, to show us the credit history of the applicants based on, of the credit history, show that information based on, in a graph format. That's just what it's doing. Same information, but in a graph format. Here for the stacked bar, so they show the same distribution in there. And again, this is just profiling. We're not changing the data, we're not doing any modification, just doing profiling and analyze what kind of data that is in there. Again, the structure of the data, the columns, the aggregation functions that are being applied to those, that could be applied to those. And in here, yet another graphic to show the loan status on the credit history education, depending on the education, the combination of them. So if you have, if you are not graduated and your credit is very low, actually is graduated, right? Your credit is very low and you're graduated, you have a slight chance, a better slight chance to get approved. If you don't have a graduation, the score is very low, you're almost certain that you're going to be denied. On the other hand, you see the information in there. So all of this we are doing, we did up there on the script was just to analyze the data, look into the data, see if the data makes sense, and we learn from the data. In here, we are going to start working with the data frame in order to, as they say here, to do some data. Sorry. What they call it here, some data mugging, right? And preparing your data. You're going to work with some aspects of the data and do some fixes on the data. In this one here, they are creating an element, a Python asset called a Lambda Function, which is, I want to make a calculation. The calculation I want to make is I want to do a sum of all the values that will be passed in here. And if the value, see the X, let me zoom in here. If this is the value that's being passed, and we are creating a total, grand sum of it. But if this value that was passed is null, null means there is no data, so it doesn't count for the element, for the sum, for the grand total. What we want to do is actually have some information in there. We can replace that information, that absence of information, with some data that a subject matter expert could tell us. It's a good idea to have this medium information here, and you got to be very careful, right? You have to think these things through with this mean, because you are introducing data that was not there, just to avoid noise on the data set. There we go. Here again, missing data. So we fill up data with, fill up rows with standard values when there is no data in there. So for the loan amount, I want to have a loan. I don't know how much money I want to borrow. Can you borrow me some money? And then I got like, the person did not tell me how much money I want to borrow, so I'm gonna make an analysis based on the mean of all the values that I have that applied in there. So those guys who did not ask the money, they did not have unlimited credit, they're just gonna fall in the middle of regular applicants that being request credit from my company. So that is the one. Let's go and check that one, see how that looks like now. So let's go over here. Loan amount. We got 22 in here. We had 22 empty loan amounts in there. Now we have 0 loan amounts because we just added the information here, like I mentioned. Here, right? And if we count, we see that we have the amount, all the rows fill up with that guy. That should be, well, it's not showing here, but we should be looking for the one with about 6 or so. Anyways, self-employed. What about self-employed? So let's take a look on the self-employed information distribution there. What? Process that? Nope. It doesn't want to process anymore. There we go. My hotkey here decided not to work. Yeah, so here they're doing the data profiling, analyzing it for the box plot. We use the box plot visualization for self-employed and for education. If you are, no or yes, approved or not approved for the loan amount, and here for the graduation and the data distribution for those. If I count here the self-employed, I see that there are 582. So there are some missing ones. So what do I do about it? Well, let's check out what is the percentage of no's against the yeses. So the percentage of no values is 85. So meaning 85% of the applicants are employed. The other 15 or 14, right, almost 14, are not employed. So they have decided to fill up the self-employed with no, because it's the majority of the cases when there is no data there. So we run this again, and now we see that the self-employed has all rows filled up with data. And you always want to have data in all features for all rows, because no data disturbs, right? It messes up the machine learning statistical model when training the model. One last one here. Let's see, this one gets a table of the distribution, self-employed, graduate, not graduated. So this is the distribution of the table in there. And I'm going to save you some of the steps in here. This is a function in Python that is going to be used. It's called fetch, right? Define function to return value of this pivot table over here. And here it's using the fetch function, which gets an argument, x, that will be whatever loan amount is going through there, and doing that calculation that was done over there. So when I go into the info now, I will see that the information was filled up. Actually, no, it's not there yet. Yeah, it's not there yet. This one is the loan amount. When the loan amount, so for the loan amounts that were left empty, we do this page with the calculation of the mean that we have discovered before. All right. Okay. Some other corrections in here for the loan amount. Now the distribution is like that for the range, when we define it by range in bins of 20, in clustering ranges of 20. This one here for the applicants, there's way less outliers. Data seems to be more well balanced, creating like a line regression in there. with that, they in the workshop, they're like, okay, we're good with our data now. The data was kind of sparse, full of some outliers. We removed some of the noise that was in there. Now the data seems to be more well distributed. So it's time to start landing this plane, right? It's time to build our predictive model. Oops, sorry. To build our predictive model, to train our model. And here in this Python code here, they're going to work with the information and data frame to create, make sure that there are no more empty rows in there. And here's a logic. See, there is a loop going through the rows to fit the transformation. Oops, for the data. There we go. For the data. And when we look into the, you got the data types for the numbers the way they're supposed to be. And when we run and analyze the code, we see that all features have data for all rows. So that, you see, I told you, the bulk of the work of a data analyst is going through the data and trying to get the data arranged in a way that it makes sense for model training. It's different from a data engineer that we just get the data transformed to a particular standard, and if it's missing values on the rows, that's just the way the data came from the source. So here you have all these considerations, applying all of these considerations. It says over here that cell that now we can finish the model and import the libraries that will do the model training. So they're using new libraries in here. See, they're importing new libraries that did not refer up top. So let's double check if the scikit is imported. So pip install scikit. Okay, it was already there. Perfect. Which means I can run this cell, because here, when I make this call here, see, when we make this call here, fit is when we train the model. And when we make this call here, predict, is when we use the model that has been already trained to create the predictions, right? To calculate predictions on a set of data. And in this case here, this is just a function. There is nothing being processed at this point. It's just create a function that will process. And it looks into the model we want to use, the data for training, the predictors, the features, and the outcome, right? The scoring of the elements, and the model fits down here for the outcome. So let's create this function. This is one way of doing it. One particular style. Okay, train. That worked. And now it did not train. I'm sorry, create the function, right? We're still going to train. So outcome feature, right? We want to, this is the one that we want to calculate, is our label, the loan status. This is the statistical model we want to use. That's the reference for this session, the logical regression. And the prediction is in the, based on the credit history data frame with all the information from the data frame. So let's run this guy. He just trained the model. And based on the calculations on the credit history on the second parameter here, see on the predicted var, this is the model, this is the data frame we had used before. Let me zoom in here. This is the model we elected, we want to use, right, and test out the, how good it is. Again, the training data set, the column that gives the label that has the information that is supposed to be calculated, and where we want the model to output the outcoming data when calculating the predictions of the data. So the final accuracy, see when you do the model scoring over here, is 80%, which means when you run the data the data that the model has seen before, it was able to score about 80% on the testing model, which is not bad. You know, I have seen worse. 70, 60 was kind of bad. We want to get it higher than that usually, but we never want to have it 100%, because the 100% means it's biased, and we don't want to have that. This one here is using a different model. See, this is the decision tree classifier. If you look in the documentation, it's a more elaborate model, and using the same inputs for the decision tree. When we execute, it got 81% accuracy, while this one here was just 80%. So this seems to work better for our set of data than the other one. And that's it, right? This, I told you, creating the data set that can be used to train the model is the worst part of it. And it's the longest task you have. In this code, the code to train the model was just this one, and it took just half a second to train the model. Of course, when you have volumes of data, it will take longer than that, right? And then there is some extra challenges in here for you to try on. But that is the workshop that you can try yourself. You have all the links in there to download these assets and have fun with all of these elements. With that in mind, we're going to wrap it up over here. Hope you have learned something new and you're excited to try this on your own. And I'm going to call Faraz here to the stage and see if there are any questions.
Thank you so much, Armando. As usual, a great session. We appreciate it.
Thank you.
Everyone, if you have any questions for Armando, now it's the time. Or else I'll just post in the link for the survey. Please, if you have some moments, please fill out our Reactor survey. We'll be more than happy to hear how it went. Please put in the code 15892, and that's it. Again, if you have any questions for Armando, please ask them away, and if not, we'll wrap this session up.
All right, 7 seconds is the buffer time. 5, 6, no questions.
Okay. Thank you so much, everyone, for joining. Thanks again, Armando. Appreciate it.
Thank you. See you next one.